All right. Not for lack of interesting and unusual things happening in the wider world in a climate context, but it has been relatively quiet in California as of late, and that's about to change. We have had a heat wave recently. It wasn't anything record-shattering by any means, but it was hot, especially in Northern California, in the interior of California last week, closer to the 4th of July. It's cooled off again. In fact, it's notably cool again at the moment in some spots. But we're going to see a rather dramatic reversal once again. And now this next heat wave is starting to look like it might be more significant than the one that California just experienced. And it looks like it might have the potential to break quite a lot more records than the last one. So we'll talk about that a little bit later. But first, I wanted to address a couple of other things. The first of which is the ongoing and extraordinary spate of global record-breaking heat and flood events. We've seen a lot of these in recent summers, but this summer is exceeding even some of those recent years in certain places, and also on the global mean basis. And I also wanted to talk briefly about the emerging or evolving situation on social media and how it's getting really difficult to follow some of these things in a consistent and reliable way as existing social networks fragment. I'll talk a little bit about my personal thoughts on that and where I'm likely to be if you want to find me, since I am having difficulty accessing many of these networks. I don't quite understand why, but I'll get to that in a moment. So, as you've probably seen, if you have been online, or even in a growing number of the more traditional TV news outlets and newspapers, the Earth is currently, this week, appears to be hotter than any week that we've observed since we've been recording temperatures, actually. So, the temperatures globally over the past few days have been the highest they've presumably ever been in well over a century of record keeping. Now, I did want to clarify what's actually meant by that scientifically. We don't actually know what the exact global average temperature is even right now, even today, with precision. We have a pretty good estimate of it, but it's imperfect because ultimately we don't have thermometers covering every square inch of the Earth. We have to do some spatial and temporal interpolation, and the way we do that is often with a product that's known as atmospheric reanalysis. So if you've heard all these headlines about July 7th or something being the hottest day ever observed on Earth, that claim is coming from generally a global temperature product from one of these global temperature reanalyses that come from in the US, they come from NOAA. In the European Union, they can come from the ECMWF or other entities. Usually it's national or multinational meteorological or space agencies that maintain these data sets, where effectively are really good estimates of the way things actually are on the ground. And we do this for all sorts of variables: temperature, precipitation, all the usual weather variables. And they're generally pretty good, and they're getting better over time, but they are still estimates, and so the reanalyses don't exactly agree even on what the current Earth temperature actually is in absolute terms. So they vary a little bit from one another. And so the exact temperatures that you see from the European data set to the American data set, it's not surprising that they're not exactly the same. But what's striking is that across these data sets, many or most of them are suggesting that many of the days we've seen in the past week are indeed the hottest days that we've seen in the history of the period for which we've kept temperature records. So it's a little bit trivia in a certain sense that it's almost immaterial to the long-term warming trend. It was inevitable that was going to happen eventually, given global warming. And yet it still marks an important milestone that we're at the point now where we can measure on a given day that we've never measured a day like that day before. And that is I think it is important, certainly from a public science communication standpoint, and it is trivia that is broadly consistent with the less trivial, much more substantive long-term trends that we're seeing towards hotter temperatures globally, and all these kinds of extreme events we're seeing that come along with it, with record-breaking heat waves in many places and record-breaking precipitation and extreme flood events as well. So it's sort of I sort of have two minds as a climate scientist in terms of the relevance of the relevance of these daily level record-breaking temperature statistics. On the one hand, I think it's entirely appropriate to be talking about them because it is representative of the long-term trend. On the other hand, I don't think the fact that a specific day is apparently the hottest in a given reanalysis temperature data set is in itself a sign of anything more alarming than anything else that we've been seeing, which isn't to say that what we're seeing isn't alarming. It's just to say that it doesn't necessarily mark some incredibly extreme, anomalous short-term acceleration. It's actually just illustrating how deep-seated the long-term trend is, and that now, temperatures have increased globally to a point where when we do get a modest daily spike in temperature, it's essentially the hottest temperature that we've ever observed. So I think that angle is maybe the more concerning part of it, which is that this is something that we're going to be seeing repeatedly over and over again for the rest of our lives in most cases, where we'll continue to exceed the previous peaks. So that's sort of my perspective on the daily temperature extremes. Now, I think more consequentially, some places have been enduring extremely hot localized temperatures. So the global mean temperatures is, in a certain sense, a statistical construct, right? Because nobody actually experiences the global mean. It doesn't exist at any one place. It's an emergent mathematical property of observing the way things are. But what it's composed of locally does matter for people and for cities and countries at the epicenter of record-breaking heat waves. And many places have seen just punishing heat waves in recent in days, weeks, and months. And recently in the United States, this has happened, or in North America broadly, happened first across much of Canada, especially Western Canada, which is now experiencing just a wildfire season that has already obliterated just about all records for wildfire seasons in Canada, and we're not even halfway through it yet. So again, it hasn't broken records to date. It's broken records in many cases for the entire season, and we're relatively early in the season, so that's going to continue to get worse. But also more recently, across the far southern tier of the United States and northern Mexico, just this incredibly miserable, humid heat wave across Texas and northeastern Mexico that's lasted for weeks now. And some places have seen their all-time hottest temperatures on record, but the more impressive and dangerous part is that many places are breaking daily record high temperatures over and over again for days on end. And the absolute temperatures, these are not places that are cool. These are places that are already hot and humid, and yet they're more hot and humid than they've ever been. We're talking about heat indices, combined effect of temperature and humidity in parts of South Texas of between 115 and 120 degrees. And again, this is not a dry heat. It becomes difficult for sweating to cool you off quickly enough, even if you have access to water and you're in the shade under those conditions. So it is genuinely quite dangerous to be outdoors or working in those conditions, as many people have to do. And it's also not a short heat wave. Again, as I mentioned, this has lasted for many, many days, even weeks now in some parts of Texas and adjacent northern Mexico. So this is a very long duration event, and it's continuing. It's going to have another peak soon. We've seen similarly extreme heat waves in a bunch of different places around the world recently. The Canadian Arctic currently, yesterday reached 100 degrees Fahrenheit for the first time, I believe, in recorded history. The parts of southern Europe have been sweltering under record, and northern Africa under record-breaking high pressure ridge with temperatures at night in some parts of northern Africa. I believe it was Algeria, where it hasn't dropped below 100 degrees even at night. Again, these are hot places to begin with, but these temperatures are still hotter than we've observed in these already very hot places. There have also been record-breaking heat waves in parts of South and Southeast Asia as well, periodically over the past few weeks. Simultaneously, there have been some really conspicuous extreme flood events in the Northern Hemisphere summer. Currently, there's an ongoing extreme and even catastrophic flood event going on in the interior part of New England, so Vermont, New Hampshire, and upstate New York, where a lot of mountain roads and valley roads have already been washed out, and it looks like it's going to get worse the rest of the day today as the extremely heavy precipitation continues. We saw recent catastrophic flash flooding in parts of Italy and Spain near the Mediterranean, where again very intense downpours have caused. You've seen these viral videos of cars just floating down city streets, and ramming through the bottom floors of buildings. These are clearly high-intensity floods that are occurring. So we do expect a certain number of events like that every summer because, in fact, in many places in the world, the summer is the season of heavy downpours, thunderstorms. This is very different from California in that sense, but that is true for much of the world. So it's not that summer is an unusual time of year to be seeing precipitation extremes in these regions. It's just that we're seeing an awful lot of them, and some of them are breaking records once again. So we've seen them before to a certain degree, but what we're seeing now is breaking some of those records. So we've seen a lot of extreme heat, a lot of extreme precipitation globally, and then through all of this, California has recently been kind of chilly. It has been a cool start to the year. There have been some record cool temperatures in certain parts of the state on different time horizons over the past few months. That is about to change, though. And I think the fact that we've had those cool conditions and we are going to now potentially shift toward record warmth even in parts of California is going to be an especially difficult transition, even more so than if we'd already been hot. So the good news is, from a fire season perspective, we had a wet winter, a wet spring, a late spring that stayed cool into early summer. So in some places, especially at higher elevations, vegetation moisture is lagging even how dry it would normally be this time of year. But that may be starting to change pretty quickly as we head into this upcoming much more severe heat wave and much more, as I mentioned, much more prolonged heat wave, importantly. This will not be, like we've seen this year, a brief 1 or 2 day event. This is going to be a very prolonged multi-day event and might actually last considerably longer than a week. So I'll get into details of that in a moment. Fire season-wise, of course, we saw the expected spike in ignitions around the 4th of July, mainly due to fireworks, but also other people being outdoors. Fortunately, there were no major or very serious wildfire events in California that I'm aware of over that period. There were many small fires, but nothing too crazy. And there are currently no really large active fires in California that are distracting or detracting or absorbing, I guess I should say, lots of firefighting resources. So resource utilization in California from a firefighting perspective is currently low. There's still folks getting good fire on the ground in the form of prescribed fire in different parts of the state because vegetation moisture still accommodates that, especially going up into the middle and high elevation bands right now where the snow has only just recently melted in some cases. So as I mentioned, high elevations do not expect a severe fire season this year because of all that extra moisture. But at lower elevations, in the grassy regimes, in the chaparral, and the brush, the oak woodlands, and these mixed regimes, things now are really starting to dry out. And with this upcoming prolonged heat wave, this was a risk that I mentioned earlier in the year, that if we have all this extra growth of brush and grass, especially at lower elevations, early in the season when it remains wet and cool, and then we get a prolonged mid or late season heat event, or multiple prolonged heat events later in the season, you could still dry all of that extra vegetation out and cause a significantly active fire season despite how cool and moist it's been, partly because of how moist and cool it's been at lower elevations, because you do get all that extra growth of vegetation in what are known as those fuel-limited fire regimes, those ecologies where from year to year there is a lot of variation in terms of how much vegetation matter actually grows. And so this is a year when we may see more fires in desert regions because there's a more contiguous fuel bed of, unfortunately, invasive grasses because it's been so damp and cool. That's all grown. We've seen a couple of those down by Joshua Tree Park already. This is a year where the foothills in particular and the lower elevations could be at risk, especially during wind events, because there's a bunch of extra brush and grass, and a lot of it has continued to grow after the first cutting. So even in some places where folks have mowed to mitigate risk, that grass is coming back up and growing again. So unless they do a second cutting, which sometimes there isn't the motivation or the budget to do, that's going to come right back up. It already has in some cases. And so we may get a situation where we have a very potentially an active fire season at lower elevation up in the high mountains where there's a lot of dampness and soil moisture and even some snow still at very high elevations. So I've talked about that dipole effect before. I won't emphasize it again too much right now because it isn't really the focus of this conversation, but I do expect to start seeing the emergence of more and potentially larger fires in California and also throughout a broader part of the western U.S. In the coming days as this widespread and increasingly severe heat event develops. We've gotten a bit of a reprieve in many places up to the present, and that may be coming a bit to a close. And that's important because there's an expectation that the fire season in the Pacific Northwest could be much more severe than usual this year because of developing drought up there and ongoing anomalous heat. The fire season, as I mentioned, in Canada has been just unbelievably extreme relative to historical period, and a lot of U.S. firefighting resources have been sent up north across the border to Canada. Canada, of course, sends its resources southward across the border as well when the situation is reversed, but it does mean that there is at least partially zero-sum game here about firefighting resources shared between those two countries, and if the U.S. fire season picks up, a lot of those resources may be recalled back to the U.S., leaving Canada with fewer resources and potentially stretching both sides thin. So that's something to keep an eye on later in the summer. It hasn't happened yet because the U.S. fire season has not been very active to date, but that may be changing as things really warm up and start to dry out more aggressively in the coming days. Okay, so what about this heat wave that's coming into California? Well, it's sort of been there in the model ensembles for a while now. It's sort of been bouncing around between sort of a more moderate event and a pretty extreme heat event. The model ensembles had backed off a little bit a couple of days ago, but now they're becoming a little more aggressive again as the event gets closer. And I think I want folks to emphasize that when you look at your weather app or see something in the newspaper about the heat in the next few days, it doesn't look that extraordinary for the next 3 or 4 days in most places. Yes, hot, but nothing too extreme. But the problem with this event is it actually isn't even going to peak probably for another 6 to 8 days. So we're still a full week out probably from the peak of this event, and it isn't going to end suddenly at 7 days. It's only going to gradually fade thereafter. So it's going to be a slow build for the rest of the week, essentially, peaking maybe late next weekend or even early next week in some places, and then staying much hotter than average potentially for a good portion of the rest of July thereafter. So I think July will end up looking, there's starting to be indications, looking like a very different month than May and June did in California in terms of those months being significantly cooler than average. July is perhaps not shaping up to be that way, even though it started out that way in some places. So this will be, the key word is prolonged, but there is the potential for it to be a high-intensity event as well at its peak. And this will be a ridge of high pressure that will be most anomalous and anchored over the interior desert southwest. So there have been rumblings in the Phoenix area, for example, that this heat wave could, at least on one of the days, bring temperatures that rival Phoenix's all-time record high, or something close to it in adjacent areas. So New Mexico and Arizona could see some all-time record heat for any month of the calendar year from this event. That, of course, is saying a lot because some of the lower deserts there, those records are 115, 120, or even hotter. So we're talking about temperatures that could get up into that range there. those are also the kind of temperatures we would see in the interior valleys of southeastern California, the lower deserts, in places that get very hot during this event as well. Death Valley could well get up close to its all-time record of, I believe, 130 degrees Fahrenheit, which is, of course, a bit more of a novelty than anything else. It matters a lot more how hot it is in Phoenix and Vegas, where people actually live, than it does how hot it gets in Death Valley, but it is an indicator of how extreme the air mass might be. I was a couple minutes late to this conversation because I was looking at the most recent round of model updates, and specifically at some modeling tools that give a sense of the relative anomalousness of the heat of the air mass that is to come. And what was striking to me is that as the models have converged back again towards a more extreme heat event in the coming days for the Southwest and for California, both the American model and the European model and their ensembles are starting to indicate the potential for record heat all the way west into California, at least across the California interior. So 850 millibar temperatures, for example, which is the temperature a few thousand feet above the ground in the air, are reaching record levels for mid-July, right around July 16th or 17th, so about a week from now when I mentioned that this would peak. So there does appear to be a growing potential for this heat wave to become more extreme than the last one was, and for a number of places to break at least daily record temperatures, and in some cases potentially approach July records. So it's too early to be more specific than that, but this does look like a both longer and more intense heat wave than the one we just experienced, and it could last for a good portion of the rest of the month once it begins in earnest in a few days. And while it will be anchored across the interior of the Southwest, where Arizona and New Mexico are most likely to see record-breaking temperatures, there are now some signs that parts of California could as well, especially away from the coast, but potentially extending relatively close to the coast. So I should really say maybe excluding the immediate coastal strip. This won't be, I don't think, a September-like heat wave where we have offshore winds all the way to the beaches, but this might be one of those heat waves where the beaches stay relatively mild, but inland even just 5 or 10 miles and you're at 110 or hotter. This could be one of those kinds of midsummer heat waves. So it's a little early to be too specific about exactly how hot it's going to get, but I was not particularly impressed by this last heat wave, and although it did break a couple of daily records in places like Sacramento, it was not overall a historic heat event in California as expected. This one, it's too early to call it a historic heat event because we're still over a week out and the forecasts have been bouncing around a bit, but it has greater potential to become a record-breaking heat event than the last one, both in terms of its peak intensity, how hot it gets on the hottest day, as well as its duration. And the duration part, I think, is going to be more significant. It does look like this is going to be one of those events that stays very warm at night, which is dangerous for human health in particular, and it may be an event that lasts for many days, which again amplifies the impacts. It is worth noting that we kind of threaded the needle in terms of severe snowmelt flooding this spring. We could have had it with the amount of water that was up there, but because of the cool spring, we got lucky, and we melted a good portion of that snowpack over a longer period of time than if we had had a really warm May or June, for example. So that said, there is still snow to melt at the highest elevations, and it really is going to start to melt very fast, what remains at this point during this heat wave. So again, river flows will remain high. There could even be a couple of flood flow peaks on Merced River or Walker River, things like that, draining small to medium-sized watersheds in the Sierra. Nothing really catastrophic, but, strong currents, people go in the rivers during heat waves, and so the biggest human impact from that may be that it continues to be dangerous to go rafting in a lot of these rivers. So if you're going to go, be aware that the water will still be icy cold despite how hot the air will be, and could be flowing very fast, much faster than usual for mid-July, certainly. And as I mentioned, I would expect that fire activity will start to increase, and we may start to see some larger fires. I would expect them to be mainly at low to middle elevations, not high elevation fires, and I don't foresee any extreme wind events, so I don't think there's going to be any extremely alarming fire conditions necessarily. But I do think that we're going to start to see some more fires escaping initial attack, as they say in the biz, and going on to become larger fires that last multiple days. So I think we're starting to get into that part of the season. That in itself is not too surprising, but again, there is a lot of extra fuel this year at lower elevations. So once those grasses really cure and as that brush starts to dry out, then there is going to be a lot of fuel to work with because of how moist and cool it's been and how good of a growing season it's been for plants at lower elevations. So that will start to, some of those are going to start to pop off as well. And, the rest of the interior west is going to become more active as well. We've started to see some activity in Arizona, western Colorado. Eastern Colorado has been record wet this spring, amazingly enough, but western Colorado and points west from there have not been. There are indications that the southwest monsoon could be kind of a dud this year. Hasn't arrived yet, and there's no immediate sign that it will. So, and that's consistent with seasonal predictions of a weaker than usual monsoon. So it's a good thing that the lower Colorado Basin had a really good snow year this past winter, because if it hadn't, and then we got this what's increasingly looking like a not so good monsoon this year, that really would have pushed the crisis to a new level. But as it is, I think the beneficial effects of the good snow winter will probably, at least for this year, outweigh even a pretty bad monsoon. But certainly not solving the long-term problem, but I don't think that even a fairly bad monsoon this year would immediately bring us back to the crisis where we were last summer. So the snowy winter did buy us some time there, even if it's only a year or so, to continue to figure out what we're going to do with the broader water crisis on the Colorado River Basin. All right, so I'm about halfway through. We'll start taking some questions. There's not as many today, but I know that sometimes people wait for this period where I say I'm going to start to respond. So I'll start with what's here, and I'll assume that folks may add some more in the next few minutes. All right, here. There's a question about, let's see. There's a question from Jack. Given the recent easterly wind burst that has quote-unquote put the brakes on El Nino development, does this change the outlook for a moderate to strong or very strong El Nino? Yeah, there's been some rumblings about how the atmosphere started to look like it was responding as you'd expect to a strong El Nino, and then kind of that it decoupled a little bit, where the atmosphere now, in the tropical Pacific at least, kind of looks different than you'd expect. And there haven't been as many westerly wind bursts in the eastern part of the Pacific Ocean. So the reason why westerly wind bursts are important is that the prevailing easterlies, so east to west blowing winds in the tropics, are one of the reasons why in the Pacific Ocean the warm pool is usually in the West Pacific, and there's cold water upwelling in the Eastern Pacific. So you literally have winds that help accumulate mass of water in the West Pacific that's warm and result in upwelling of water from the cold depths of the ocean in the Eastern Pacific to conserve mass. Obviously, you can't just move water out of an area without it flowing in from somewhere else. This does result in a tilt of the sea surface that's quite significant from the western to eastern part of the basin, on the order of feet. So the ocean level is several feet higher in the Western Pacific than it is in the Eastern Pacific. But during El Nino, that gradient, that height gradient, sloshes back eastward to a certain extent. So you get both surface movement of warmer water to the east as those easterly trade winds slacken and are in some cases, at least briefly, replaced by westerly wind bursts, which helps develop and maintain an incipient El Nino event. And you also start to shut off some of that cold water upwelling. And that has happened in spades. This is off the coast of South America, and Peru in particular. This is El Nino Costero. And really, it's a coastal El Nino. It's exactly as the name implies. And this is occurring. We see this There is exceptionally warm water off the coast of Peru. We're talking like 5 to 10 degrees Fahrenheit above average, which is a huge anomaly for ocean surface water. So that has materialized. And we do see that the Niño 3.4 region, the sort of the canonical El Nino region in the central East Pacific, that is but much warmer than average, and we do officially have, I believe, El Nino conditions in place right now. But that development, at least in the central Pacific, seems to have stalled temporarily because we don't have any ongoing westerly wind bursts. We probably will see the reemergence of them shortly, but the fact we don't have them right now gives us pause a bit. It also seems like this El Nino is managing to develop just from the warmth that was subducted into the subsurface ocean during La Nina. So some of that is just emerging vertically, where those warm water anomalies are just surfacing, and that is less dependent on westerly wind bursts. So that other mechanism seems to be driving a lot of the warming we've seen recently. As that continues, we would expect that the feedbacks that occur between the ocean and the atmosphere circulation to start to develop westerly wind bursts as we go into the autumn. So this is why a lot of the predictive models sort of have predicted that El Nino will stall out at moderate intensity right around now for another month or so before resuming intensification again in a month or two later in the summer and early fall and early autumn. That would currently still be my expectation. The likeliest outcome is still a strong El Nino event this year. We're already sort of at a weak to moderate event, and all signs still indicate that it will strengthen. But there is a slight wild card. If these westerly wind bursts never materialize, that could be a conceivable failure mode for a strong El Nino event. But at this point, I think that all of the dynamical models, for example, are suggesting a strong El Nino event. In fact, greater than 99% of the ensemble members from the European model ensemble are suggesting a strong event at this point. So that's about as strong of a signal as you can get from predictive models. If it doesn't happen, it's going to be a huge predictive failure. So, I mean, that would be striking and definitely worth a conversation if it happens. But right now, I still think a strong El Nino event by this fall and into early winter is the likeliest outcome. So, talk about that a little bit more as it evolves. I still think we're likely to see those impacts. What's interesting is that the ocean temperatures, and this relates to a comment that came after Jack's question, or before, it was somewhere in there anyway, about the warm water blob in the North Pacific Ocean. What's interesting is that the water right off the coast of California is unusually cool and has been so for a while, but the water further offshore is exceptionally warm, and there is another very warm water, record-breaking in some cases, warm water blob many hundreds of miles off the coast, but only right along the coast. It's pretty cool. So you have this cool strip of water right along the west coast, exceptionally warm water closer to the center of the North Pacific, and then also exceptionally warm water in the eastern tropical Pacific associated with El Nino. So far, we haven't gotten those coastally trapped Kelvin waves that I mentioned earlier that could result in some inhibition of the cold water upwelling near the California coast that sometimes occurs during strong El Nino events. So we haven't yet seen that occur. And actually, the seasonal models have backed off a little bit on how much the nearshore waters off of California coast may warm during this El Nino event. So this summer, there's no real signal at the moment for exceptionally warm water temperatures right off the immediate coast of California, even though there's a very strong signal for a strong El Nino event and for the North Pacific blob offshore to continue to be warmer than usual. So that's a little bit complicated, and it conceivably could have some implications for precipitation-related teleconnections next winter if it persists. The models still do indicate that may go away by the time the winter comes around and the strong El Nino will really take over. But we'll cross that bridge when we come to it and have that conversation again a little bit later, I think. All right, looking for some other questions here. Yeah, a question from Paul Rogers. During heat waves like this one, people always say, well, there have always been heat waves in summer. What's my response when I hear things like that? Yeah, I hear things like that all the time. And of course it's true that the warm season is when it's warm. You get heat waves in summer because that's the warm time of the year. Or in the case of the beaches in California, sometimes the early autumn is the warm time of the year. If you spend any time in San Francisco, you know that. But generally speaking, the hottest events occur at the hottest times of year. That's not too surprising in any given location. But of course, climate change is not necessarily bringing about completely brand new types of weather. It's shifting the envelope of weather that we experience. So it's not that we've never experienced heat waves before or extreme precipitation events or floods or wildfires, but what it's doing is changing the character of those events. It's upping the ante, if you will. And so, yes, we've seen heat waves before, but when we talk about the potential for record-breaking warmth, that is relative to a particular time of year. So if I tell you, for example, that places in Arizona and New Mexico are likely to approach their all-time July monthly temperature records during this upcoming event, which does appear possible, that doesn't mean it's an ordinary July heat wave. Yes, it's hot in July in Phoenix. Nobody has ever questioned that one. But if we talk about record-breaking heat in July in Phoenix, by definition, that literally means that this event has the potential to be hotter than any other July heatwave event in recorded history in that place. So this is relative to local context, is what I'm saying. And so, yes, it's hot in July most of the time in many places, but what we're seeing this July is on a different level in many places. And ironically, it hasn't been in California so far. There's some signs that could change with this next event, but in many other places, this is already, the hottest July that they've ever seen. In parts of Texas, for example, or parts of Northern Africa, or Southern Europe, or parts of the Canadian Arctic. And so, taking the global view is one thing, but also thinking about how just the fact that, the kinds of weather events that we're seeing today are familiar. They're not completely, brand new types of weather, but they're, in many cases, when it comes to extreme heat or extreme downpours, as we're seeing in a lot of places right now, they are more extreme than what we've seen before, and that's exactly what we expect in a warming climate. Our climate has warmed. With the recent warming this summer, we're probably close to about 1.3 or so degrees centigrade of global mean warming. That's over 2 degrees Fahrenheit at this point, if the math is right. And that doesn't sound like a lot, but what it does is it actually pretty dramatically shifts the envelope of weather, and it particularly shifts the envelope of extreme weather by an even larger relative increment. Because when you're out if you're talking statistics, when you're out in the tails of the distribution, in the sparse part of that spatial and temporal land where events occur very infrequently because they're so extreme, a relatively modest shift, a degree or so, brings about an enormous change in the likelihood of actually experiencing that event in the historical period. Same thing with extreme precipitation. 5-10% more extreme rainfall. It doesn't sound like a huge increment, but if you increase the extremity of extreme precipitation by 5, 10, 15%, and that is the amount by which we've generally done so in most places with the amount of warming we've already seen, it can result in big changes in the likelihood of seeing really extreme events. And it can shift the tail of these distributions. It can shift the extremity of these events by more than it seems by these changes in the mean. And it's not even necessarily because the extremes are shifting in a dramatically different way than the average, although they are in some cases. But it's simply just due to the way that the statistics work. The heat event that occurred in British Columbia and the Pacific Northwest, for example, back in June 2021, is estimated to be hundreds, if not thousands of times more likely to have reached the magnitude that it did because of climate change. Even though, in some cases, climate change probably only contributed somewhere between 3 and 5 degrees Fahrenheit to the magnitude of that event. It still would have been an extreme heat event, even if it were 3 or 5 degrees cooler than it was. But the fact that it was 3 to 5 degrees Fahrenheit warmer than you could have foreseen in a climate without the warming that we've experienced actually puts it in a completely different level. And it definitely increased the impacts that we saw from that event as we see this in other ones. So this is a bit of a tangent now, but that's the long version of the elevator pitch when I get that sort of comment, which is on an almost daily basis, actually. There were a couple of questions about social media and Twitter. I do want to address them. I'll do that at the very end. So I'll collectively answer everything about YouTube and Twitter right at the end of this conversation. Let's see here. There's a couple of questions about arc storm and El Nino, and although it's not the focus of today's conversation, I'll briefly address it. In the work we published last year, we did find that the highest likelihood of widespread, extremely heavy, month-long sequences of precipitation in California definitely do, in the model world, occur during moderate to strong El Nino events like we are expected to have this year. And there's been a lot of comments about how El Nino doesn't matter for California precipitation, and I understand where that's coming from because often the connection is overblown or misunderstood, and it's viewed as this binary thing. El Nino means wet, La Nina means dry. That's not how it works. El Nino and La Nina are but one of many relevant factors. But I think that maybe we've gone a bit too far back in the other direction of saying El Nino tells us nothing. I will say that weak El Nino and La Nina events really don't tell us very much because they're just not strong enough to exert a statistically meaningful influence in the long run. But strong El Nino events and strong La Nina events, to be quite frank, they do exert a really strong influence on global climate that does affect California precipitation. And so in winter, at least, other times of year it's a bit harder to discern because we don't have as much precipitation outside of winter, so the signal is inherently weaker. During strong El Nino events, despite the fact that the last strong El Nino event did not bring an exceptionally wet winter to most of California, that was 2015-2016, I would still make the prediction that if and when a strong El Nino event repeats itself and is in place during winter, as looks fairly likely to occur this year, that the odds of a wet winter definitely go up for most, perhaps even all of California, partly because the effects of El Nino are nonlinear. So you can't just do a correlation between the Nino 3.4 index and California precipitation and expect to see anything meaningful. You have to look at the tails, the statistical tails of the distribution. You have to restrict your sample to the extreme, the strong to extreme El Nino and La Nina events. The problem with doing that only with observed data is there's only a few events of each on the observed record. It's really hard to get a statistically meaningful result when you do that. So that's, I think, why folks have resorted to doing just simple correlations between Nino 3.4 ocean temperature index and California precipitation or runoff or things and come to the conclusion that it doesn't matter. I think this is a category error because what we really care about are the effects when the system is far from its mean state, and those are not the same. They're not even linearly scalable with when the system is slightly outside of its mean state. Weak El Nino events, weak La Nina events are the most common types of events that we've observed, and so they get weighted de facto more heavily when you do a simple correlation between these two things. And when you do that, you're going to miss the fact that if you restricted your sample to the strong events, that you actually would get a meaningful signal. This is one perspective, I think, where it helps to be a climate scientist sometimes because we're used to running large ensembles of models and repeating the same experiment many times over with slightly different initial conditions and getting sometimes quite wildly different outcomes from individual ensemble member to member. But overall, when you run this model ensemble 100 times, you might get 2 events that are crazy dry outliers. You might get 2 events that are crazy wet outliers. And then you might get a nice distribution that shifts somewhere on one side of average or the other. So I will say this, if we had been able to observe 100 strong El Nino events in history, and really we'd have to go back centuries or millennia to do so we just don't have that observational data. we would probably have a very different picture. We'd have a more nuanced view and say, okay, yeah, well, with the strong events, they're usually wet, and sometimes they're very wet in California, but not always. You can still get a dry year during a strong El Nino event, but it's a heck of a lot less likely to get a dry year during a very strong El Nino event than it is to get one during a very strong La Nina event. The problem is we don't have the long enough observational record to discern that for the most intense events. But we do have modeling tools, climate models and weather models that we can use to build those synthetic large samples. And when we do that, when we run these climate models, which have pretty good representations of El Nino in many cases, at least the ones that we've used for this purpose, what we see is that 8 or 9 times out of 10, a strong El Nino event will be a wet to very wet year in California. But 2 out of those 10 times, it can be dry. So what does that tell us? It tells us that we have to think probabilistically. We can't think 2015, 2016 was a strong El Nino year that wasn't super wet in California. And so therefore, we can't say anything about the relationship between strong El Ninos and how wet it might be in California. That's just not correct. It doesn't follow from the science. When we take nuanced views at ENSO and extreme El Nino events or strong El Nino events, time and time again we find strong relationships between California precipitation and those events. But if you look at weak El Nino events, it's true. There's really not a lot there. And we shouldn't expect there to be, because El Nino, ENSO in itself, is a coupled nonlinear process. It's coupling the ocean and the atmosphere, and it very much matters the details of the spatial pattern of where the ocean temperature anomalies set up and things like that. So I'll talk more about that later in the season. It's still pretty early in the year. We don't know exactly how strong El Nino will be. If it ends up not being a strong event, then I would not necessarily make a strong prediction about California winter precipitation, but I think it probably will be strong, so I may be making that having that conversation with you in a future session in the not too distant future. But I did just want to reflect on that a little bit. Please don't rely on average correlations between Nino 3.4 index and California precipitation to conclude that it doesn't really matter for California precipitation. That's just not correct, according to our current physical understanding of how strong El Nino events versus strong El Nino events alter the global climate system. That said, there's a lot else going on this year. There's climate change, which is always throwing a wrench in things. There is the legacy of that massive Hungatonga volcanic eruption last year, which injected all of that water vapor into the stratosphere, which we still don't fully understand the regional climate implications. It does look like it is responsible for about, say 0.05 degrees centigrade of the additional warming we've seen this year. So that may not sound like a lot, but it probably is a detectable increase in global average temperature at the moment, which might be very slightly contributing to the magnitude and frequency of the record-breaking heat we're seeing around the world. I'm more interested in how it might be affecting regional atmospheric circulation. Might it be playing a role in why California was so exceptionally wet last winter for no obvious reason, and why it's remained, so far this season at least, which may be changing, quite cool to date. Record cool in a couple of spots. So that's another factor that's out there, and I've talked about some of these other competing factors just to illustrate that El Nino is the most predictable and probably the most pronounced factor in the year-to-year variability that we know of. In the long term, though, it's global warming. That's the most important factor in terms of our stair-stepping upward over time. And in any given year, there can be other factors as well. Wild cards, like, who would have thought that a massive nuclear-like blast from a volcano under the ocean in the South Pacific would have, affected global climate potentially in the way that it has. Very differently from how other historic volcanic eruptions have affected the climate, where many of them have cooled temperatures for a couple of years. Well, no, not this one. This one, just our luck is it's probably exerting, if anything, a warming effect due to all the extra water vapor in the stratosphere, which is, of course, water vapor is a greenhouse gas. So there's a lot going on this year. Everything's kind of crazy. And then I wanted to close talking a little bit about social media. I still am on Twitter, but it has become impossible to use as a reliable tool for disaster and real-time information gathering. It is very unreliable. There are many search terms that when I search them, they just get error messages. Don't quite understand what's up with that. I was restricted from viewing tweets for the better part of the past week. It looks like that has now mostly resolved. But the long and the short of it is, I think that it's lost credibility as a real-time source of emergency information, certainly, and I'm finding it more and more difficult to find information, and people I don't know how much the algorithm has changed, or whether it's just not, people just aren't there anymore. I don't know exactly what the reasons are, but that has been my recent experience, although I am still there as my primary place to post real-time short increments of information. Folks have asked, I have a Mastodon account, but I'm not actively there. I'm currently paying for an IFT applet just to repost Twitter content there, because I just do not have the bandwidth to be very active on multiple platforms at once. So I don't know what's going to happen with Mastodon, but it's currently tied to my Twitter posting. I do have an account on Blue Sky, which I know is not available to everybody, but honestly, it is in my personal opinion, the best replacement for Twitter. I know it's currently still invitation only, which is very frustrating, which means it's not a mass media source in the same way that other platforms are. And unless it becomes so, it won't work for me in the long term either, because I am trying to reach as broad an audience as possible. However, the plan for that platform is for it to become publicly available sooner rather than later. We'll see how quickly that happens. But it does have, critically, two things. The search feature works well. You can find exactly what you're looking for. And B, the platform is inherently reverse chronological. So you actually see the newest content first. That is not true of other social media platforms right now, notably Threads, which is just this random amalgam of what the algorithm thinks you'd like. In a weather and emergency disaster context, you're going to be seeing tweets from weeks or months ago mixed in with things from the last 5 minutes, because there is no way to set the timeline to be reverse chronological. For me, at the moment, that means that it is not usable for real-time information gathering or dissemination. The other problem is that I have not been able to sign up for it, and I have been in touch with engineering folks over at Meta, and so far I haven't been able to figure out why I can't sign up. So no, I'm not on Threads. I did not have an Instagram account previously, and so I don't know maybe if that's the problem, but I haven't even been able to get a foot in the door. Somebody told me that there was some impersonation going on already over there. I can't verify that because, again, I can't access any content because I can't sign up still after a week of trying. So long story short is I'm not very enthusiastic about Threads, and I'm not on there because I physically can't get access. So I would encourage folks who can to follow me over on Blue Sky for now, which has been a very good experience, very positive, very Twitter-like experience. But I do realize it is not yet a mass messaging tool because it is not open to the public yet in its beta version. But it will be. That is, to my understanding, that is the goal. It's a mess out there, honestly, and it is an incredible shame that Twitter is not what it once was. I mean, it was just an unbelievable tool. I know there's a lot of folks, I think, in the media world and in the science communication world who are despairing far more than any of us thought we would over a social media site. It's really kind of amazing, as we're only realizing now in retrospect, what we had with it and how unbelievably useful it was when used constructively. There's a lot of harm that, of course, comes with a lot of social media too. Twitter was no exception to that, but Twitter was, I think, unique in the ability, if you used it in the right way, and you sort of leveraged the reverse chronological nature of it, and the fact that you can search for almost anything and immediately access domain experts on almost any topic who will speak to you directly. I found that incredibly useful, and so I tried to use it in the same way to respond to people who would ask me questions. I hope that gets replicated somewhere. I'm not convinced that Threads is designed in a way that's going to, but I know it's going to evolve. I know it has a huge user base, so maybe I'm wrong. But right now, the most promising and I tried Mastodon to be active there, and honestly, even as a very tech-savvy user, I found it extraordinarily confusing, and I could not find anything that I was looking for. And even though claims that there's no siloing, I was then told that I was on the wrong server, which was confusing because I don't know what server I want to be on. I'm in the weather sphere, I'm in the climate sphere, I'm in the academic world, I'm in the public policy world, the wildfire world, the flood world. Twitter was good because you didn't have to pick. You could do all of those things at once. Blue Sky is the same way. I don't know how Threads is going to be because I can't get there. And Mastodon, my main experience over there was people complaining that I wasn't more active on the platform. So to be quite frank, it's frustrating. I don't have the bandwidth to be on all of these social media platforms. I just can't do it. It takes an enormous amount of time and capital to build up a presence like I had on Twitter, like I currently still have. I don't want to necessarily use it past tense. I'm still holding out hope that things turn around there, and I am still there. I'm not giving up on it. I'm not going to delete my Twitter account ever, but we'll see where the balance of posting shifts to. So currently, again, I'm most optimistic about Blue Sky, but the clock is ticking on the ability to make that public and to have everyone to have access. So I hope that happens ASAP. But for now, you still can find me on Twitter, with the major caveat that I am often restricted from posting for unknown reasons, and the ability of the platform to remain online appears pretty unstable these days. So in an emergency, I think it's going to be harder to rely on. Personally, of course, if you're here and listening to this, you know that I'm doing these YouTube sessions now frequently. I may continue to ramp these up. They seem to be really successful. People seem to like them. I do, of course, have the Weather West blog as well. I try and update that every couple weeks. The challenge is it takes a lot of time. I have to take about half a work day usually to write a blog post, get all the images, publish it, and check on the status of the website that day. Twitter, social media is helpful because it allows me to just put things out there quickly without a lot of investment of consecutive hours of time. So I will still be on the lookout for short-form, text-centric, reverse chronological, searchable social media. We'll see who emerges as the new leader there. But you still can find me here, of course, on YouTube. This is one silver lining to the disillusion of the one singular social media site, which is that it did push me onto YouTube, and I think this has been incredibly valuable. I do like this platform. It turns out that these live sessions are a lot easier for me to do than pre-recording things, and so I think a lot of folks find them more valuable as well. So I will continue to hold these office hours. You can still find me on Twitter. We'll see how long that lasts. I am trying to ramp up on Blue Sky, but I don't still have as much content as over on Twitter. I can't access Threads, so I mean, that is what it is. The Weather West website remains. If anybody is thinking of starting a new social media platform, feel free to reach out, and I'll give you my opinion as a science and a disaster communicator on the kinds of features that are critical. Or if you work for one of these existing platforms and want to make them better, seriously, this offer stands. I'm happy to have a conversation about how to do that from the perspective of disseminating both scientific information on the one hand and real-time information about natural hazards, disasters, real-time news events on the other. All right, I think I'm going to wrap that up. And thanks everyone for joining. Sorry for the technical difficulties at the beginning. Maybe I should just log into these 5 minutes early in the future and let them resolve themselves. I don't know why that happens, where the connection seems to get better progressively and the audio filter seems to work better and not amplify my fan noise. So I don't know. But I'll get my new office set up better, and hopefully this will be less and less of an issue moving forward. Thanks again, everyone, for watching, and as always, this will be recorded and available at higher video quality resolution in an hour or so as long as it takes YouTube to render the video. Talk to you all later, and I will try to have a blog post in a day or two, depending on how this heat wave pans out. It looks like it could be pretty significant, so I will try and have at least a new short blog update in that window. All right,